Well, hi everyone, and thank you very much for having us. My name is Trey Nunn, and I'm a GIS analyst with Tessellations. Today I'll be presenting with my colleague Benny Patel. It's such a great opportunity for us to be able to share with you all some of the projects that we've been working on. And today we specifically want to share with you a project that involved working with real-time traffic data in Austin, Texas, and some of the processes we developed working with that data. Before we dive into that though, I'd like to spend just a minute to introduce ourselves. So Tessellations has been around for over 22 years, providing a wide range of GIS and technical support. We support the full stack of Esri products, including Desktop, ArcGIS Pro, ArcGIS Online, Enterprise, you name it, we support it. Other business focuses have been in software development and data management, image processing, and even training. Our clients have included a number of oil and gas companies, but we've also done a lot of work for the local and state governments. And we are partners with Esri as well as Safe Software, Planet, and Microsoft. So this whole project can be thought of in four main parts. The first part is how we keep our GIS data that we maintain on our side, how we keep that updated and in sync with the live feed provided by Austin's data portal. In this next part, we look at ways to best visualize the data as it's being updated and refreshed. And then once we have a good collection of the data, and then we've backfilled all of the data that it has provided by Austin's open data portal back to 2017, and we can run some really cool, really major, big analyses on the data and identify some trouble areas around town. Then we can take a look at these incidents as a specific point, as a specific traffic incident, and perhaps help users link to that existing traffic incident any pertinent related documents that may exist, such as police reports or even images of that traffic incident, all directly within the user interface of the map. So I've mentioned FME a couple times, and so real quick I just wanted to go into what is FME. So FME stands for Feature Manipulation Engine. It has ETL capabilities, which that means that it just has the ability to connect up to 450 different types of data formats and applications. And then within it has a whole suite of tools that allow you to transform and manipulate the data as you work within it, within a workflow that you develop. And then whatever workflow you do develop, you are able to automate those to have and run on a regular schedule. The FME workflow that we developed does quite a bit, and it only takes a few seconds to run. The main tasks that are involved in this workflow, firstly, is connecting to the data source, and that data source is an open data portal API, and we feed into it a couple parameters when we request the data. And when we request the data and pull it down, within the workflow, the FME workflow, we do some manipulation to the data. And one of the main ones that we can think of is really going from one data version to another. And that's going from the original source data, which is in JSON format, to tabular rows. And we'll need to do this because eventually this data is going to feed into our GIS data set, and we'll need to convert to an appropriate format. The next thing is that we need to format some of the attributes that are coming along with this data. Namely, we want to be able to spatialize the data, so we'll pull out the latitude and longitude information from the data source so we can spatialize it using some of the built-in tools in FME. The next part within the same run in the FME workflow is detecting the changes in the data. So like I said, we're running this FME process on a regular basis, and specifically we're running it every 15 minutes. And so every 15 minutes it's connecting to the data source, pulling down traffic incidents that have occurred, and we're running through the spatializing and reformatting, and we're detecting the changes that may have occurred since the last run. So let's say a scenario is a traffic incident has occurred 20 minutes ago, and we picked that up and reported it as a new traffic incident. We wrote it to our database, and then now we're running it again. This time that traffic incident has closed. It's been cleared since the last run, and so we'll update our database accordingly. So it's no longer reporting as an active traffic incident. It is now closed or archived traffic incident, and we'll update our database accordingly. If that traffic incident is still active, then we won't make any changes to the database, and then with that specific traffic incident, and we'll keep that live until that incident has been updated accordingly. And then the next thing that we'll do is once we have this FME workflow built and developed, we can schedule it on a scheduler, and that's what we've done. I mentioned that we're running this on a regular basis every 15 minutes. There's a couple ways that we can do this. We can set a batch file to run with the Windows Task Scheduler. And also, if you have FME Server, you can configure FME Server to run any workflow that you develop in FME and have that run on a schedule as well. So with that in mind, let's go ahead and take a look. So let's open up and take a look at FME and what that looks like. So here we have our FME workbench that we developed to allow us to connect up to that open data source of the traffic incidents and manipulate it and format it as it comes in as we run this process to allow us to write out to our GIS data set. And we have this run on a regular schedule every 15 minutes. And basically what's going on here is we have a couple parameters that we set within this workflow that we developed. And one of the all the parameters for this project are over here. And so one of the first parameters, and maybe most important one, is the location of the data and where that data source is. So we'll have the URL here as one of the parameters that we'll call on and one of the tools that connects up to that API. And then we have a couple of other parameters here that help us define a where clause that we'll also use in that data request. And so the first one here is that number of days to keep. This basically helps us write that where clause and develop a date range. And then the statuses that we're looking for in this data. The statuses here we're looking for if the incident is active or is it archived. And so each time this process runs, we connect up to the data source. We look for data traffic incidents that have occurred within the last day, and we pull those down and we run it through our process. We set up a few parameters to help us call that data and some of the tools that we use. But basically we set the stage here, and then we go and the data goes and follows the arrows here and works through some of the all of the tools that we have lined up here. So one of the big tools that it goes to is this tool, and then in FME we call these tools, they're called transformers. And this one is green because it's a little different than the other ones, because this is a custom transformer, meaning that it represents a whole series of other tools that we've developed that in actuality can be called on and used in other workflows as well. And so to take a look at what this looks like, we can open it up in this tab here, and you'll see it has its own set of tools and transformers that are being used. And so as the data passes through that custom transformer, the green one on the previous page, then it runs through these tools. And this is really where the magic is happening, where we use this HTTP color transformer, and based on our set of parameters that we have, that URL that we defined, as well as some of the other parameters that will help us write the where clauses, we make that connection and request the data based on those parameters. And then once that's made, then we pass through a few tests, and here's where we actually do the conversion from the original format, which is in JSON, and convert it to the required tabular format that will allow us to write it to our GIS data set. And then so as the data runs through here, it runs through these tools, and then it steps back into the main workflow where we do a little bit of attribute cleanup and manipulation to allow us to step into the next process where we'll actually be spatializing. So we'll use a set of tools, obvious by their names. The first one is the vertex creator. We'll use the latitude and longitude information coming in from the original source data. We'll define the coordinate system based on the metadata that's provided by the open data source. And then we do a few other conversions and manipulation to the data to make sure that it writes and it's friendly to write to our SDE feature class. And then finally we'll do a comparison. And this is where we'll compare to active incidents that we've already reported on versus active incidents that have now closed since the last run, and we'll update those statuses accordingly. So we're identifying new incidents that have occurred since the last run, as well as updating existing traffic incidences that have closed since the last run, and then we write those new records and updated records to our GIS feature class here. Now that we have the FME workflow in place and we have it to run on a regular schedule every 15 minutes to keep our GIS data up to date, we can start to do some really cool stuff with that data. And one of the first things that we can do is just quickly visualize that data using a dashboard of sorts, such as this one. So we developed this dashboard around that traffic incident data. We pulled out just from there the year 2020 data to enable us to quickly view and maybe identify some patterns and visualize the traffic incident data. So from here you can see that there's quite a bit going on. It has all the traffic incidents for just 1 year, 2020, and here we are in November, so there's quite a bit. But you can see from some of the other elements that are in this dashboard some pertinent, important information. So one of the first things you can see is this top right one is the current active incidents that have occurred today. And so there are currently 5 active incidents on the road right now. And then there have been 25 traffic incidences total today. Then we can get a breakdown of the type of incidents, and this is the top type of incidents that have occurred to 2020. And you can also do some kind of running count of the data. In this case, for the whole year, there's been over 1,000 incidences of just loose livestock alone. You can quickly see a breakdown by day for the last week, and you see kind of a trend that's going on through the week, as well as you can do a year to date. And this one is very interesting to see because you can see for the last 11 months kind of a low trend. But if you go to the beginning of the year, you can see it's kind of quite a bit, over 3,500 traffic incidences that occurred. Then you had COVID hit, and then quarantine happened, and you see a significant drop in traffic incidents that were reported. And here we kind of rose back up, but still kind of kept a low number compared to what we entered the year in. And so this is a pretty interesting observation just from visualizing the data alone. There's other things that you can build into your application. We can see those active incidences, which ones are active, by toggling on and off just active, as well as based on what those active incidents are, the type of incidences that they are. Then we can also go back to our week, and then we can look at back to all of the traffic incidences. And we can query based on different dates. So we can look at the traffic incidents that occurred today. You see those 5 active incidences still, as well as some of the other incidents that have already been closed. So we can look at yesterday's by clicking those, and then turning off those queries by clicking outside. So there's some powerful things just by visualizing the data alone, but that definitely the story doesn't stop there. With such a large data set that we've gathered so far, we can start to do some other cool things as well. We could start running some really cool analyses and maybe identifying some trouble areas in the traffic incident data that we've gathered. So I'm going to pass this over to Benny, and she's going to cover some of the analyses that we ran on the data.
Thank you, Trey. Trey showed you how we can take this near real-time data and put it on a dashboard, kind of get a situational awareness picture of what may be happening in the field at any given time, using ArcGIS Online or Portal. Now what we're going to do is kind of take a deeper dive and say, can we derive some insights from looking at this data? It's a lot of data that we're collecting over time, and there's got to be some way of looking at it and saying, are there any patterns, are there any problem areas that we should be looking at proactively? So if you kind of sit back and squint your eyes a little and look at this image, you'll kind of see places where it looks like the points are clustered way more than other places. So that clustering can be statistically significant or not, and that's kind of what we're going to look at. So if I turn off the actual points, and what you're looking at now is essentially an aggregation of those points and an analysis to identify hotspots. And you can see there's multiple hotspots all around Austin, and we're going to focus in on this one on the northeast side and take a deeper look at that. So what we'd like to do is, one of the first things we need to do is, if we're going to do a hotspot analysis, we have to somehow aggregate this data. In this case, what we chose to do was use the Getty's or G-star hotspot analysis, and in order to do that, we had to create a space-time cube. So in this case, what you're looking at is essentially a space-time cube generated by using these hexagonal bins, and these hexagons are about 1/4 of a mile in radius, in width. And we're saying, hey, if there are incidences within 1/4 mile of each other, let's go ahead and cluster those together. And then, because we've got so much data over time, we want to also look and see if there's any time-related trending happening. And so we created a space-time cube. The cube size, or the individual bin, is about 1/4 of a kilometer, and then in terms of the time, we've aggregated to the month level. So when you look at this data using these bars, you can see each one of these horizontal bands is kind of a month worth of summarized data, and then each one of these bars represents about 1/4 mile hexagon area. So what we're looking at here is essentially how things look different over time, and you can see some rods some are really red all the way through, and some are kind of red and hot and not hot sometimes. So if we look at just the red hexagons at the bottom, which are considered persistently hot, what we're looking at there is essentially most of the rods are hot all the time. And when we say persistently hot, with the Getty's or G-star, what we're doing is we're saying not only if I am high, that's great, but for me to be considered a hotspot, not only do I need to be high, but my neighbors need to be high as well. And so when I look around me, I'm comparing myself to the whole extent of the data that I'm looking at. In this case, it's the Austin area, and for me to be considered a local high, I have to be statistically high, not just on my own, but with my neighbors as well. And that's how we get the hotspot analysis. The other thing that's we also chose to do was an emerging trends hotspot analysis, which essentially then says it runs a second statistical analysis on it. And essentially what it's saying is, I want to not only look at the hotspot, but I also want to look at time. And it runs the Mann-Kendall trend test and says, are these hotspots emerging? Are they getting hotter over time, or are they getting cooler over time? And in this case, we can look at the legend here on the left-hand side, and you'll see that all our reds are new hotspots, and all the radial colors are essentially trending hotspots. So they're intensifying over time, and then the speckled kind of red is just essentially the sporadic. There's no real trending on that right now. So this kind of gives you an idea, and for this data we had actually, I forgot to mention, what we did was we pulled out just the collision data. So once we've done this statistical analysis and we know that these are hotspots, what other information can we derive out of it? So we did another thing, was we turned around and said, okay, we're going to focus in on this area to the northeast, and we want to kind of see if there's a pattern on time of day. So here what we're looking at is essentially the 7 days of the week broken out, as well as the time of the day in a 24-hour period. And you can see there is one clustering that seems to be a little high here, which is between 6 and 8. And then we've got a second clustering, which is high between 3:30 and 5:30 or 3:30. So we'll just say from 4 to 6 we've got a high. You can see Saturday and Sunday are low, but right here, Friday, people going home at the end of the week seems to definitely spike. So people are either in a rush to get home or get to happy hour or whatever it is. We're definitely seeing a spike on Fridays in the evening rush hour. So if we know that there are changes on daily trends, can we look at that data a little closer? So what we did then was we said, okay, let's look at the morning incidences, which are all these in yellow, and then let's look at the afternoon period. We essentially sliced out 2-hour periods, so morning 6 to 8 and evening 4 to 6. And is there overlap in some of where these incidences are occurring? And you can see some are standalone yellows and blues, but a lot of places those are overlapping. So in order to find problem roads, what we did was we took these actual incident data and aggregated them up to the street segment level. So once again, you're looking at street segments. We counted the incidences up by segment, and here you can see the segments that are high in the morning, segments that are high in the evening, and once again we ran the regular GREDIS or G-star hotspot analysis on it and identified segments that were high and low. And sure enough, this is kind of what the picture you're looking at. These are all the high segments. And what's interesting is if you look at this little street segment here, it's high in the morning, it's high in the evening. Nothing else seems to be terribly nasty around it. But so you have to ask the question, why is this particular segment high? You know, what's so special about it? And so we wanted to say, look at it and say, can we derive, is there other information out there that we can actually derive some insights into why this might be happening? And so we looked at, now I'm going to take you into ArcMap and I'm going to show you a little more data. So then we chose, these are the same points, these are the same segments, but we then said, hey, can we get the actual incident reports? And sure enough, TxDOT has a crash database, which essentially when an officer goes out and fills out an incident report, that goes through their local system and then eventually gets put into the TxDOT crash database. So we said, all right, can we go to the TxDOT crash database and get any additional information on these points? So to give you an example of what that looks like, we are now using LinkIT, which is essentially a tool we've written here at Tessellations that lets you take your map features, points, lines, and polygons, and link them to any other information that's sitting outside of the GIS. So any referential information that could be of value, they could be sitting in file folders, they could be sitting on websites, they could be sitting in other databases, doesn't matter. But can I pull in information about these features that are not in the GIS? And so we've got this tool that lets you do all of that, and it's basically hyperlink on steroids. It lets you link to whatever documentation's out there. So I'm going to give you an example. I'm going to swipe this red point here, and it's going to go backwards. It's going to search and come back with a JPEG, which is a photograph of the incident, and it comes back with the TxDOT crash report. And if you notice, there's a case ID here that's going to be important in a second, and it just gives you an idea of what might have happened here, so you can look at the reports. And to show you a little about how this LinkIT tool works is essentially there's an index out there, and the index, all it does is, in this case we've got Austin traffic incidents index, and what the index does is says, okay, go index the file name, the path, any update whenever new documents come out, or remove old documents, and index this particular folder here. And this folder is essentially folder with documents. It's got reports, and all of that. And it's basically going to go look at this directory, and when I say start indexing, it just runs through and indexes everything that's in that folder. So in this case, we've got 12 records, 12 files. It went through and indexed them and told me it's ready. So once this index is being created, what we do in the LinkIT tool is essentially point to our feature class. So you can see we've got Austin traffic incidences here, and it's got something called a report ID. And the report ID is the same thing as a case ID in the text.database. So we're saying for that report ID, go point to this index that I've just created and find an exact match. So basically what it's going to do is every time I click on a feature, it's going to take whatever is in that attribute field report ID, take that string, pass it to this index, and find an exact match in the documents. Now, in this case, we're going to keep it simple and say find me the exact match, but you could do containing words, all words, any words. There's some advanced search capabilities where you can do sounds like, you can even do synonyms, so the search capability is pretty robust and powerful. But in this case, we'll keep it simple. When a feature is clicked with the LinkIT tool, it takes the contents of report ID, sends it to the index, and retrieves documents. Now I want to quickly show you something else about this, is if I hit one of these green points, it goes back and retrieves nothing. So now I'm going to quickly go through and show you how new documents can be added very easily. So this is the folder that essentially where all the reports are and that index is picking up. So now we got some new documents, and I'm going to put new reports into the reports folder. I've got some new photographs that came in. I'm going to copy those and I'm going to put them in the photographs folder. And so essentially when the index is scheduled using Windows Scheduler and it's running on the back end, as often as you like. So when I come into the office the next day, I know I've got some more data that came in. I go click on some of these points, and sure enough, it goes back and it comes back and finds the new documents that have been added. So in this case, there's more photographs that were added. There's more reports that have been added. So essentially what it's doing is running the scheduler, updating the index, and at the ArcMap level, the user has to do nothing. When new reports and things come in, it will automatically be plumbed and ready to go. So now for a quick recap, we took that near real-time traffic incident, which is getting reported every 15 minutes. We used FME to process it and put it into SDE, and then that is getting pushed out into ArcGIS Online or portal, and you can look at all that data, visualize it, and look at, have a operational dashboard that tells you what's going on in the field at that time. And then we went ahead and took that same data and took it into Pro and analyzed that data to find problem segments, and can we do some forensics around it. Once we've actually found segments that are high, for some reason they're hotspots, we can then link it to the Texas crash report and look at it. And so essentially we can look in our office and kind of do a lot of forensics around why some of these incidences may be high, and then go out and mitigate. So essentially this is a full life cycle of some real-time, near real-time data getting utilized. And with that, I'd like to end and open it up for questions. Once again, thank you to NCTCOG for giving us the opportunity to present today. And now you can put in your questions either in chat or unmute yourselves and ask the questions. Thank you.